Hi folks, in this tutorial we will be analyzing the number and types of orbitals present in a typical atom. Analysis of these orbitals will enable us to know their relative energies and to rank them accordingly. Such rankings will lay the foundation of the Aufbau's principle that guides how electrons are to be inserted into atomic orbitals when doing electron configuration. These figures depict the Bohr-Rutherford diagrams for the atoms of the elements helium, neon, argon, and krypton. They also show the number and types of atomic orbitals present in each atom. Helium with 2 electrons has this spherical orbital here that is called a 1s orbital. Neon also has a 1s orbital that is found in its K shell, along with a bigger s orbital that is called a 2s orbital, as well as 3 dumbbell-shaped orbitals that are called the 2p orbitals. And these here comprise the L shell. Argon has all that neon has, along with this large s orbital that is called a 3s orbital, and these 3 larger p orbitals that are called the 3p orbitals. And these here comprise its M shell, that is that shell there. Now we come to krypton, but before we show the orbitals present in the atom of krypton, we want to note one difference between the M shell of argon and that of krypton. For small atoms such as argon, the M shell here can only accommodate 8 electrons. However, as the atoms of the elements get bigger to a certain degree, this M shell here can accommodate a total of 18 electrons. So this is the deal. As the atoms become bigger and bigger, where they can hold up to 18 electrons, this M shell here must be filled with electrons before we can insert other electrons into the N shell. While small atoms such as argon can only hold 8 electrons, larger atoms such as krypton, their M shell can accommodate a total of 18 electrons, and these must be filled first before we can insert electrons into the N shell. Again, following the same pattern, krypton would have everything that argon has except for 2 differences. So krypton is going to have all of these orbitals here that are present in argon except for 2 differences. One will be that there will be more orbitals in the M shell because of its greater accommodating capacity. So these orbitals here can only account for 8 electrons in the M shell. So we need to show how the other 10 electrons, because this has 18 electrons, are accommodated. And this is where these 3d orbitals come in. There are 5 3d orbitals here, and each of these can hold 2 electrons. So in total these can hold 10 electrons, and this single 3s orbital here, and along with these 3p orbitals here, will hold the rest. However, we now have to talk about the orbitals that are found in this N shell here. You have 8 electrons in the outer shell, a huge s orbital that is called the 4s orbital, and 3 very large p orbitals that are called the 4p orbitals. Like we said before, one of the objectives of this tutorial is to determine the energies that are associated with these orbitals. To arrive at the correct electron configuration for atoms, electrons are first inserted into the orbital or orbitals with the lowest energy, and then into those of higher energies. An orbital that is closest to the nucleus would have the least energy than those that are farther away from the nucleus. So we will now try to rank these orbitals in order of lowest energy to highest energy. But before we do that, I just want to point out something to you here. These d orbitals are not arranged like we have them here. They're actually grouped together around the nucleus of the atom. If you try to group these together, we can have something like this. So putting all the d orbitals together, we will have this ball of orbitals here. Doing the same thing for the p orbitals, for the 2p orbitals, we have a structure like that. The 3p orbitals, we're going to have that. The 4p orbitals, we'll have that. The s are going to be by themselves. So this is what we'll do. We'll try to rank the orbitals in terms of the amount of energy that they possess. So if we suppose that we start with this 1s orbital here, of course the 1s orbital will be closest to the nucleus and it will have the least energy. So we now go into the other shell, which is the L shell, and the L shell will have these two orbitals there. So we're going to superimpose these orbitals over each other like that and see which one is closest to the nucleus. Right now you can see the 2s orbital will be closer to the nucleus than these 2p orbitals there. Put that over there. So we'll have, first of all, we'll fill in this 1s orbital, and then when electrons are left over, it's going to go into those 2s orbital there. Now take this one here and put it at the back there. I just put in these at the back there so that the ones at the front can be seen, so we can make comparisons in terms of their energy. So that's the second shell. In the third shell, we're going to be having this 3s orbital. So why don't we superimpose these on each other like that? Let's take the 3s and put it there. Definitely the 3p orbitals are farther away from the nucleus, therefore we should put the 3s now there. Then let's compare these here, 3p and 3d. You can see that the 3d orbitals are farther away from the 3p. So now we can put these 3p orbitals there. We're not done with the third shell yet. Next thing we have to do is to see whether or not these d orbitals here are more energetic than these 4s orbitals. Definitely you can see that the d orbitals on the average are farther away from the 4s orbital. So we'll take this 4s orbital and put it there. Then why don't we look at the 3d orbitals and the 4p orbitals? Okay, definitely the 3p orbitals are farther away from the 3d orbitals. So we now take the 3d orbitals, put them behind there. You can see how they're bulging out a little bit farther away than this 4s orbital there. And we now take this, we now take these 4p orbitals and put them at the back there. And this is how these orbitals here are ranked in terms of energy. So I have a little structure here that I've done for you. I've grouped them all here. Okay. The one with the least energy is the 1s orbital, followed by the 2s orbital, 2p orbital, 3s orbital, 3p orbital, 4s orbital, 3d orbitals, and 4p orbitals. So when we will do electron configuration for atoms, this is the order in which the orbitals must be filled up. First you fill the 1s orbital, and what is left over go in the 2s orbital. When those are filled, you're going to put them in the 2p orbitals, and the pattern continues like that until we end up putting electrons in the 4p orbitals. And there are other orbitals that we talk about that need to be filled after the 4p orbitals. I have the structure that I've made here to give you a better semblance of how these orbitals are arranged. Okay, so you can see something that is more concrete. Let us assume that we cut this model in half. This is what you're going to see. So on this side here, we're showing how the orbitals are arranged with respect to the nucleus. In the center here is our nucleus, and that nucleus is surrounded by the first orbital here that is shaded in black that we'll call the 1s orbital. Surrounding the 1s orbital is this other larger spherical 2s orbital. And represented by these lobes here are the 2p orbitals. This one here is coming out of the nucleus there, but the other half you can't see that is found at the back of that nucleus here. So quickly, we have a nucleus, we have the 1s orbital, the spherical. Then surrounding that 1s orbital as well as the nucleus is this larger 2s spherical orbital that's shaded in green, and then you have these p orbitals. And I want you to see how they're farther away from the nucleus than this 2s orbital. That is why you say that they have more energy than the 2s orbital. Next is from this other bigger spherical 3s orbital that envelopes everything. So we can simply say that the 3s orbital has more energy than the 2s orbital and these 2p orbitals. However, you can also see that there are 3p orbitals. One lobe is here, another lobe here, another lobe here, another lobe here. Of course, one is going at the back there, and the other one is coming outside. We close that up there. Okay. We can now see the 3s orbital here with these 3 sets of p orbitals protruding from that. Surrounding all of that is this 4s orbital. Why do we have the 4s orbital before the 3ds? This is so because the 3d orbitals are farther away from the nucleus than the 4s orbital. So in doing the electron configuration, you'll have to insert electrons into the 4s orbital before you start putting them into the 3d orbitals. So these are the 3d orbitals here, and these are the lobes coming out there. I hope that was beneficial to you. Our next tutorial deals with energy level diagrams on electron configurations. Stay tuned. Please don't forget to subscribe. Thank you.